Alright, looks like we are live. So I'm going to go ahead and check the audio real quick. Check, check. Check, check. Alright, sounds like the audio's good. Sweet. Give it a couple of minutes for people to file in. This is the first Makerspace Month workshop, 3D printing and design. This is a hybrid workshop, so you may not be able to see me on the virtual end, but you can at least see what I got on the screen. And if you were to attend, we got a whole computer lab here where you can follow along. But for those of you following along at home, just sit back, relax, and see if there's anything about 3D printing and design that interests you. We're going to be talking about not just 3D design, but also 3D printing, different types of 3D printers, and just things that you can do with a 3D printer that you might find interesting. For those of you who are not familiar with a makerspace, we are the Oak Hill Collaborative Makerspace. We've got a lot of tools down here. Robotics lab with tools, robots, microcontrollers, sensors, you name it. We also have, as I mentioned earlier, learning lab, just kind of 15 computers all set up in a classroom type setting so that you can follow along. We have a multimedia lab with digital audio recording and some video capability. We have some instruments as well in there, and a whole suite of very useful software that you can use to create anything from podcasts to music to even a radio show. We, of course, have a 3D printing lab with multiple 3D printers. Most of them are going to be FDM. We're going to talk about what that means later. And we also have some computers with design software on them, such as Tinkercad, Slicer, Design Spark Mechanical, just software that you would use to kind of plan out your projects. And we have some woodworking tools, materials in the back area. We have a CNC router and a whole bunch of power tools just waiting for a project. But enough about that. Let's get into this week's presentation. As you can see, we've got a different presentation for every Wednesday this month. It's because we are celebrating Makerspace Month. We kind of came up with this on our own. We felt we have a lot of wonderful tools here that we can use these workshops to raise awareness about as well as teach skills. So if you couldn't make it today, don't worry. Next week, I encourage everyone to attend in person as we're going to be going over 2D design and using a Cry-Cut, which is kind of like an automated vinyl cutting machine to create stickers and designs. So without further ado, we'll go ahead and pop open our presentation here and put it on slideshow mode. Sweet. All right, so for those of you who have attended Digital Inclusion Week, this slideshow might look a little bit familiar. We've also ran this talk a few times just to kind of get people interested into 3D printing. I would say you don't really need to know anything going into this. So if you feel like you have to play catch up, let me assure you, you don't. A lot of what we're gonna be going over is very simple to understand. And without further ado, let's hop right in. You're listening to Anthony Hake. I'm the Director of IT here at the Oak Hill Collaborative, and I've been working with the 3D printers just about as long as I've been here, going on 3-4 years, something like that. So I'd like to think I know a thing or two about 3D printing. But if I get anything wrong or you have something to offer, by all means, put it in the comments. So just very quickly, with 1,000-mile high view, what are we going to be going over today? We're going to start with what is 3D printing. We're going to briefly touch on the history of it. This isn't really a history class, but to know where we're going, we gotta know where we've been. And we're going to talk about what I think are the 4 big steps of 3D printing. If you follow these 4 steps every time, 3D printing will make sense no matter what type of printer you're using. We're going to touch on consumer versus industrial, as there is a difference. We primarily focus on consumer printing here, but if you ever get into additive manufacturing as a profession, you may be working with higher end machines than you may find in our makerspace. We're going to go over some of the types of 3D printing, such as FDM, which I mentioned earlier, fused deposition modeling, stereolithography, selective layer sintering, metal printing, and bioprinting, which I think is just the coolest. We're going to be doing a hands-on session for those of you who attended in person, which is opening up Tinkercad, getting your design off the ground, or just finding something you like on Thingiverse and getting it ready for the 3D printer. There won't really be a Q&A section for this live stream unless there's any questions in the comments. I can address those at the end. But if you do have any questions, my contact information will be on the last slide. Or you can come down to Makerspace Night next week, and I'll be happy to answer any questions you have in person. So let's start with the Big Apple. What is 3D printing? We've seen it in schools, libraries, everyone's talking about it, but really, what is it supposed to be? And I think the best definition so far is a digital fabrication of prototype materials. When you're 3D printing something, you're generally making it in 3D for the first time. When you make something on a computer, you are 3D designing, but because it's on a flat screen, you kind of really don't have an idea of how it's going to feel in your hands. So 3D printing is used to kind of make that first instance of a 3D object using effectively cheap materials that you can iterate on over and over. So if your first version isn't great, you make your changes and then you reprint it. If you were to do this with a metal printer, it may get a bit more expensive, but we'll talk about that here in a bit. 3D printing will always use computer-controlled tooling because the idea is that these motors are effectively a robot following assembly instructions, following robot instructions to create 3D objects from digital files. 3D printing is unique compared to scratch building because it has a large range of materials and therefore a unique economy of scale. So this means that you are going to be able to create very high-end materials using 3D printing or very low-end materials. And either way, you're not really going to have to worry about what the deviations between those materials because the machine handles a lot of the production. So let's get this history lesson out of the way. Now, before there was 3D printing, there was traditional machining. There was casting, molding, machining, joining metal parts via welding, spot welding, things like that. 3D printing kind of took that and put it on its head. When you try to cast something, when you try to mold something, it's very resource intensive. It's very expensive. And the machines that are required to cast and mold and join, none of this is cheap. So 3D printing was an approach to manufacturing that was meant to have minimal waste, to be able to make something iteratively over and over without costing hundreds of dollars, giving you a larger margin of error when trying to develop something new and trying to create your product. Now, the upfront cost of 3D printing was kind of insane. Like, it was very expensive to have a 3D printer out the box, and therefore it was generally for manufacturing businesses to kind of replace their more specialized machines. As time went on, however, Adrian Boyer thought, what if we just made 3D printers that made other 3D printers? What if we made these parts replaceable by making them replicable using the 3D printed parts? And as a result, it kind of blew open the door of open source 3D printing, taking this idea that everyone should be allowed to contribute to this project, and it should be available for free so that people can keep contributing to it. And that is the RepRap project, which Adrian started in 2005. Now, we've since then taken that idea of 3D models and kind of expanded upon it with websites like Thingiverse or search engines like Yegi, where you can kind of upload your designs, or even you can go on Shapeways and sell your designs to other people who kind of want to skip all the 3D modeling and get right to the 3D printing. So let's talk, what are the 4 steps of 3D printing? If you kind of work out this workflow in your head and follow this guideline, generally you're going to end up with a very nicely printed model. You're going to see on the right there that there's different ways to kind of adhere a model to your bed, such as tape. You can create a brim or a raft structure, which is effectively increasing the surface area of your 3D model, making it stick better to the bed. That's a form of post-processing, I'd feel, or maybe not quite post-processing, but when you're 3D printing, you want to tell the slicer to include this type of support for your model so that it doesn't go flying off the bed the moment something goes wrong. Before we even get to that point, we're going to design the 3D model. There is other software such as Blender where you can create this 3D model from a square and just kind of change the curvature of the faces. You can change where the angles are, make more angles, more vertices, more edges, until you have something as complicated as a human face. Blender has kind of a steep learning curve, however, and takes some time to get used to. We recommend, if you have access to one, you can use a 3D scanning machine. A lot of the newer iPhones and smart devices are coming with 3D scanning capability to where they can kind of guess what a 3D object looks like. If you don't have access to that, there is a free computer-assisted design program actually made by Autodesk called Tinkercad, tinkercad.com. It's free. It is all online, so you don't have to download anything. You don't have to have a super fast computer. You just create an account and start tinkering, start putting shapes together, and see if you can make something that resembles what you want to print. Once you got your 3D design put together, you need to put it in a format that the computer understands as a 3D file, kind of like how we have songs in MP3 or documents in docx file. .stl is sort of the standard format for 3D objects when you're about to 3D print them, and it just includes mesh data or the collection of layers and faces that kind of culminate to make that 3D design. The next step, kind of like when you have to print off a document on your paper, when you're printing something 2D on a piece of paper. Oh, hey, we got some in-person attendance. I'm not crazy. I'm talking to people on the internet, I swear.
I believe you.
So when you're preparing a document to be printed, what happens behind the scenes is you're kind of spooling it. And what spooling means is converting that text document into a format that the printer can understand. And a regular printer is a very simple machine. In fact, it needs instructions that are very simple to understand how to print something, as simple as send the print head to the left, drop ink at these specific spots on the paper. And 3D printers, they're very similar. They're so simple that they can't really take an STL file and just make it into that 3D design that you've made. You need to use what's known as a slicing program to put it in a language the printer robot or the printer brain can understand. And that's why we needed it in STL format, because without that STL, we wouldn't be able to convert it into instructions for the 3D printer, also known as G-code. Once you have your G-code ready to go, depending on your printer, you may be able to just send it over the cable or send it over a network. The 3D printers that we have here at the Makerspace, you kind of have to load the G-code onto an SD card, which is like a storage device, and then you plug that SD card into the 3D printer. Now there's some kind of, we call it pre-processing that you have to do before you just start printing. And this may include heating the bed, heating the head, cleaning any debris off the bed, calibrating and leveling the bed to make sure that one side isn't higher than the other. And if you'd like to see how to do those things in person, you would have to attend in person. I could just hold a camera up to the 3D printer as I do it, but I found that gets a little shaky. So if you want to learn how to do kind of the fifth step of preparing a 3D printer for a print, by all means, stop by. So let's talk about consumer versus industrial. These are two different ends of a spectrum that include the variables cost versus function. And this is the same for just about anything in the world. When you're trying to buy a printer, there's office printers that are very expensive, but have a lot of functions that would be useful for an office, such as fax, scan to email, so on and so forth. Functions that you may not need at home. 3D printers are very similar, sorry. It starts with desktop 3D printers, also known as countertop 3D printers. These can be DIY kits like 3D printers that you build yourself, or they can come pre-assembled from the manufacturer and just require minor calibration. These are generally the smallest, and they're the most consumer friendly. There's not a whole lot of pre or post processing to get your model looking the way you want. You just pop in the file into your slicer, convert it to G-code instructions, and then put that file onto your printer and watch it go. There are mid-range 3D printers. We consider these the prosumer choice. And what prosumer means, if you think of it in the context of consumer versus prosumer, consumers kind of buy a product and then they use it. A prosumer will buy a product and then use it to make other products. So if you have a small business that involves 3D printing parts for a large machine, or even something as simple as 3D printing jewelry and selling it on Etsy, you would be considered a prosumer. And there are 3D printers that are more accommodating to those kind of self-starters, such as those that have larger beds and can print more models at a time, more instances of a model. There are 3D printers that print metal, print ABS, print all sorts of different filament that wouldn't necessarily be relevant for someone who just kind of does it as a hobby. And finally, there are industrial 3D printers. These are very large scale machines. We're talking like they're about as tall as I am. And the idea is these 3D printers are used to offer a 3D printing service to clients, or they may be used to create large components of a car, or there's even some 3D printers that will print an entire house. I'm not kidding, look it up. It's actually pretty neat. But these have parts and applications that are specific to that industry. So a 3D printer that prints a house isn't going to make you little trinkets to put on your necklace, for example. All right, so let's talk about the different types of 3D printing, because when I say we're going to be 3D printing something, that's the same as saying we're going to drive a car. It doesn't really say anything about what the car is. Is it an automatic or a manual? Is it a Formula race car? It's just a generic way of describing the process of additive manufacturing. Now, when we get into the different types, this kind of gives you an idea of what you're going to be making with the 3D printer. For example, fused deposition modeling. Let's just start there. Fused deposition modeling, it's the most common and it's the easiest to learn. It is where you take filament, plastic or ABS. ABS is another component or type of plastic, and you kind of push heated filament through a very small nozzle. And the printer has instructions to place this filament at certain spots on the bed, kind of like toothpaste through a tube. You just squeeze in the toothpaste onto the bed, and then when it finishes a layer, it goes up by one increment and repeats the process until it's completed all the instructions in the file, and you have yourself a fully printed, looks like a boat here. Now these different layers or faces are all unique instructions in that G code. And if one deviates or if one gets messed up, it's going to reflect that in your finished 3D print. And let's say if you have a cone-shaped model with larger faces towards the top, that means the model is going to take longer to print as it gets closer to the top because there is more in those later faces that need to be printed. Something to note, why you would use FDM. First of all, it's affordable. Second of all, you're not really super concerned about density or the strength of the model. FDM prints are typically, they have like solid walls, but on the inside of the 3D prints, they're going to be hollow with infill patterns, such as like rectilinear, hexagon, pillar. I've even seen pentagon type infill patterns. And you're not really going to see these because they're on the inside of the model. And the idea is that they're going to reduce the density and the cost of what you're 3D printing. But because it's not uniform, if we were to take that boat, for example, put it on its side and then hit it with a hammer, it would break immediately because the wall on the outside is the only really solid part of the model, whereas the inside, being the weakest, would kind of crumble under that kind of pressure. So fused deposition modeling more or less describes the technique that you're printing. Like I said, it's from bottom to top. And you can use a wide variety of different types of materials. The common one that we use here at the collaborative is known as polylactic acid, PLA. There also exists ABS. I'm not even going to try to pronounce that one. But the main difference between PLA and ABS is that ABS is more flexible, and when it does finally break from being bent, it doesn't break into shards or splinters like PLA does. So it's better for wearables. You can also do FDM printing with nylon, polycarbonates. There's a whole lot of things that you can kind of get on a spool and then feed into your printer. Two things to note about FDM printers: FDM printed models. They're not always waterproof, and they are not isotropic. They are not equally dense on all sides. What is resin printed models, also known as stereolithography. This was kind of the first type of 3D printing to really hit the consumer market because it was easy to make, but it's very messy to deal with. Essentially what happens is instead of squeezing heated filament through a nozzle, there is a vat of liquid resin that gets blasted with UV light that moves around the 3D printer, hardening the resin at specific spots in the print. And as a result, because it's kind of blasted from this UV light from all different angles, it is equally strong and isotropic and sometimes waterproof, depending on how it's printed. The issue with resin printing is it's not only messy, but it's also carcinogenic. Resin shouldn't get on your hands. Definitely don't want it in your eyes. And if you ingest it, you're in trouble. 3D prints typically need to be cleaned after they're done to get all the excess resin off. So you have to put them in a vat of alcohol almost. And there's also, to kind of increase the hardening of the resin, you have to put them in a UV vat where they just kind of sit and cook for a while. As a result, you get very nice 3D prints that are much more detailed than PLA, but that detail comes with the added struggle of more effort and more work being put into the model. So our next type of 3D printing, one that you're going to see less of on the consumer side of things, but maybe this is more of a middle ground between consumer-based printers and industrial printers. This is called selective laser sintering. It's kind of similar to resin printing, but not really. Essentially, you're going to have a lot of metal powder just kind of in a vat or in a enclosed environment, and a high-powered laser is going to fuse that metal powder together in specific spots, kind of like how resin printers harden the liquid resin in specific spots while printing. And the cool thing about selective laser sintering is not only is it used to make either a nylon or a metal print, but the cleanup is typically pretty easy. When you print supports on a FDM printed model, you typically have to break them off, either by hand or with a pair of electrical wire cutters. Selective laser sintering, however, you just pick the model up and kind of give it a good shake, and all the excess metal powder just falls away. You can also just use compressed air. One of the major downsides with selective laser sintering is it makes very heavy, dense prints. There's really no way to control the infill or how dense the model is, but and they're also very rough. They have kind of a sandstone type texture to them, which is not great for wearables in the slightest. So you'd more or less want to use this for machine parts or anything that needs to be tougher than your average print. Jet technology is kind of it's a mixture of other types of 3D printing. It is there's two nozzles typically, and you can do multiple colors or you can do multiple types of prints. You can have one nozzle doing PLA, and you can have one nozzle doing resin, and have that resin nozzle just print the supports for the model. That way, instead of tearing off the supports with your bare hands, you just put them in kind of an alcohol bath or put them in a solution that melts away that resin, and you're left with the PLA or the left with the non-resin component. Sorry. Lost my train of thought there for a minute. So metal 3D printing is also a thing. It's different from selective laser melting, or sorry, it's different from selective laser sintering because metal is heated up to extremely high temperatures and then kind of poured out of the nozzle, similar to FDM printing, but instead of melting the filament at 230 degrees Celsius, you might be printing it, or yeah, you might be printing the metal filament at, I don't know, 2000 degrees Fahrenheit, whatever the melting point is of stainless steel, titanium, aluminum. You just want to reach that point so that the metal can be poured onto the print bed. Now, an area of 3D printing that is still relatively new but always interesting to keep track of is bioprinting. We are getting to the point where we can 3D print tissues and cells and have them put into our body. As scary as that sounds, it's actually based on items that we have in our body already. So this would be useful for the immunocompromised who can no longer make their own cells for some reason, or need a large amount of tissue replaced that isn't going to replace itself naturally. So generally, these bioprinters are going to build the scaffolding or the support, effectively, of a cellular structure, which is made out of collagen, gelatin, silk, things that you would normally find artificially in artificial like bio prints that get added to the body. Um, Now, there's a lot of different types of bioprints, and if I were to go over all of them, we'd be here all day. But there are some that need to be exposed to UV light. There is bioprints that kind of need to be prepared to be inserted into the body, because if you just take it off the print bed and insert it in someone's arm, you might just cause the exact opposite of what you're trying to do, such as the body rejecting the new cells. So each type of bioprinting generally takes a different type of post-processing before it's added into the body. If you bioprint something correctly, the body will kind of recognize it either as a blank template or something that it itself can use. So it'll start multiplying those cells just as though it were real tissue. All right, so we've reached the hands-on section, and unfortunately, I cannot take you with me. So if you'd like to learn the hands-on aspect of 3D printing and less about the history and the academia of it, come on down to the Oak Hill Collaborative Makerspace. Every Wednesday we're open. We're open late because we want to be able to show you how to do these things, and we try to stay open even after you're off work. Um, Yep. So this is, like I mentioned, this is an older slide. So we do not have a intros to PC class coming this Friday. That's long gone. But we do have more workshops coming up this week. I can put, or not this week, this month rather. I can pull those up again. We had 3D printing today. We got Cry Cut next Wednesday. We're going to go over some of the goals that you want to have in place if you plan to become a drone pilot. So we're going to talk about the safety test. We're going to talk about what kind of drones you're allowed to fly without a license, what drones you need to get registered, kind of the rules of flying drones. We welcome everyone who already flies drones to kind of bring them down and show us how it's done. Otherwise, it's just going to be me outside flying my drone. And on the 27th, we're going to be holding a special workshop in our digital audio recording lab. I'm going to show you how you can use an application called Amplify to very easily make your own music. So that's all I got for you today. If there are any questions, my email is anthony@okhillcollaborative.org. My phone number, that's my office line. If you want to hit me up and chat sometime, there it is. Otherwise, this has been the virtual elements of 3D printing and design for Makerspace Month. I don't see any questions in the comments section, so if you have any comments after watching this video, after it's been put up as an archived video, you know to reach out at the email on the screen there. Thank you all for having me, and happy making. Goodbye.